Oh, is that mine? Yay. Okay, I'm going to take a minute to plug two things. So the first one, if you haven't heard already, hopefully if you're in this group, you've heard about this, but we are hosting an event in Tulsa called Django Girls. It is a free programming workshop for women. It's a Friday night install fest followed by a Saturday all-day tutorial. Kimberly in the back actually did this last time. I don't know if you want to describe what the experience was like.
It was great. I really did it for women who are just getting started with web development. I enjoyed it because I want to learn some Python. Just kind of a low-key, casual, work with the tutorial together along with other communities. It was great.
Cool, yeah. So it is, yeah, just like Kimberly said, I'm repeating on the mic for the streamers, I guess. But basically, a great intro for first programming and also a great intro for if you're wanting to add Python and Django skills to your existing skill set. So that's coming up. That is March 23rd and 24th. The deadline to apply is actually March 5th. It says March 2nd here, but you can apply March 5th. So just go to djangogirls.org/Tulsa to apply for that. Or if you know someone who may want to, go ahead and share that with them. The other big thing to plug is, again in Tulsa, our web developer conference coming up called 200OK. This is May 18th. It is at the Tulsa Library, the same place we had it last year. We just wrapped up our CFP and are going to announce our speakers on March 5th, and that is also when the early bird tickets will go on sale. They will probably sell out. They have sold out last couple of years, so if you want the early bird tickets, then put March 5th on your calendar, and otherwise also put May 18th on your calendar. Save that date for 200OK. So I think that's it. Are there any other Techlahoma announcements that I'm missing? Any other workshops or events, Kimberly, that you can remember? Right, so the first Tuesday of every month, right? Yeah, so first Tuesday of every month, Techlahoma Hack Night. It happens here in this room, and we also have an event going on in Tulsa, 36 degrees north. So there's Techlahomans hacking on things. Bring your laptops, bring your code, bring your projects, bring your questions and your chat. That's pretty much it. So now we can jump into the main topic for today. So this is very much a user research and user experience project that we did. So I guess real quick, so my name is Luke, and I am a privacy and security engineer for Firefox. One of the main areas that I am interested in is the privacy and security protections that we can do inside of Firefox that will not break the web for everybody. So there are a lot of sort of security and privacy dials that a lot of browsers have, and they don't necessarily turn them all the way up to 11 every time because it breaks a ton of stuff on the web. So when I was joining the privacy and security team, I really wanted to do a study, do some user research, and find out what the current landscape of sort of the web breakage is under different privacy and security protections. So that's a little bit of how I got into this, and then what this presentation covers is essentially a study that we did in August of 2017. So pretty recent. We'd probably like to refresh it pretty soon, but real quick, we had an interaction designer. I was the security engineer on it. We had a product manager, and someone from our browser measurement team and someone from our data science team. And really what we did is we built on top of years of privacy and security work that was already in Firefox, and we just wanted to study what was already in there. So there's been these existing claims sort of floating around Mozilla and to a larger extent the sort of online privacy community and world. We have a feature called tracking protection, which is a block list of trackers, and we block connections to those trackers when you're running with tracking protection. And so there's always been this fear, this concern that tracking protection breaks websites. So it absolutely does. We get bugs filed against it that say that it does, but we don't really have, other than bugs filed, like a really good handle on what the amount of breakage is. So another sort of concern is that broken websites make users leave Firefox. So it doesn't matter if Firefox has all the privacy and security protections in the world. If people aren't using it, then they're not actually getting that protection. So this is a classic trade-off that we face in privacy and security, is if you create privacy or if you create security at the expense of usability, nobody uses it, nobody's secure, right? So you have to have both security and usability. And then sort of the last one was, are there existing things in Firefox that we could use that would actually protect users with very minimal breakage, right? So I'm going to dig into sort of each of these claims, and the way that we did this was we launched what's called a Shield study. In Firefox, we have a tool called Shield, which some of you may be familiar with if you've heard of recent Mr. Robot things, but if not, that's okay too. So in any case, it's called Shield. It allows us to basically send add-ons either on an opt-in or an opt-out basis to Firefox users. So what we did is we recruited users. Whenever they saw Firefox, there's a little banner at the top that said, we'd like to improve Firefox privacy. Would you like to participate in a user research study? And someone would click yes. When they click yes, we had this opt-in page here, improved privacy settings. We told them exactly what we're going to do. And then when they click try improved privacy settings, we would install an add-on. And this add-on had a little let's get started page that says, we've enabled a few privacy features and we need your help. If websites appear broken or they're not working, we want you to report the problem. We've put a new button in your browser that lets you report the problem, right? So when they click that button on a web page, they have two big buttons here, report a problem or this page works well, and some little text there to disable the study if it's basically breaking things so badly that they have to get out of the study for some reason. When they report a problem, we give them some types, so where the image is broken, video layout buttons, something else. And then we also had a comment box. I really loved, I kind of didn't know why we wanted the comment box at first, but after we got the data back, I was so happy we did this. And I wanted people at Mozilla to start saying the word quantitative, but nobody likes that except me, because it was qualitative and quantitative, but nobody cares. So anyway. And then we just have a thank you for reporting, so you could close the window. And then importantly, we had this disable the study. So this was put there because if one of the things we turned on was breaking your web experience so badly, we wanted you to be able to get out of the study completely, go back to normal, and we ended up measuring this data as well. So that's basically it for the UI. That's all we did. We deployed that, and then we'll go through, now this is the quantitative part of the numbers. So we deployed this, we recruited over 19,000 users. We had them in 9 different branches or arms of this experiment, including one of them was the control. Yeah, so this is more easy. This slide is really just showing that all of the only thing we did in these different branches was to turn on a preference that's already in Firefox. So a lot of these things, if you went into your privacy and security preferences in Firefox, you could enable these things if you wanted to, but we just wanted to deploy a study that turned some of those on for users and then asked them if they broke the web. So real briefly through this list, there was a control group we did absolutely nothing to. We just gave them the button. The session-only third-party cookies. This was, if you've heard of third-party cookies, every time you close Firefox, we destroyed all the third-party cookies. So that's an option to help protect privacy and tracking. Tracking protection, like I mentioned, is a block list that blocks all connections to known third-party trackers. Resist fingerprinting is something, it's a feature that we've uplifted from Tor, and it's actually enabled by default in the Tor browser. It disables a lot of features in the browser in order to resist fingerprinting attacks that happen for people.
Sorry, I'm probably jumping ahead. Tor browser, that's what you use to search the dark web.
So yeah, the question was, Tor browser, is that what you use to search the dark web? And yes, and if you want me to give a dark web talk, I can do that too. But we'll do that another time. So another one was origin-only referrer to third parties. This ended up being a really cool one, but essentially there's a referrer header that is sent that enables a lot of tracking on a per-page basis. And what we did was we trimmed all of the path information down to just the domain so that somebody like Google Analytics or something, it didn't know which page of WebMD you were looking at. It only knew that you went to webmd.com. So it didn't see what you were actually looking at on WebMD. I love to use the healthcare ones because then people are like, oh, wait, there really is, that could be interesting. So the other one, no third-party cookies. We just didn't allow any third-party cookies. First-party isolation is basically a way of double keying cookies. And then third-party cookies only from sites that you've visited. If you've heard of Apple's intelligent tracking protection, this is similar to that, where you have to visit a site in a first-party context before that site is allowed to have third-party cookies with you. And then first-party isolation to opener access is just a tweak on first-party isolation. It was supposed to reduce breakage, but we got to measure that. So with all that being said, we had up to 8,500 active users in our busiest day of the study. And we get back to these claims now, looking at the data. So tracking protection, breaking websites. What was really, really cool was we had one way that we cut the data was the average problems reported per user. So this is just given, 2,000 users, how many total problems were reported in this branch, and then divide by 2,000 users. So how many problems on average. In tracking protection, the reported number was actually lower than our control group, where we didn't actually turn on any protections. So we always I love this moment when I'm doing this kind of research. Well, first I hate it because my first thought is there's a bug in my code, right? So, oh crap, I messed something up. I better go back, fix the bug, find out, like I've ruined this whole study and months of people's lives on this. And then you go, oh wait, no, the code actually did it right. Like, no, this is the actual live result. So whenever I get surprised by this, I also like this because it shows me that whenever I built this study or this research, I didn't build it in a way that just verified my own assumptions, right? Yeah. What's that? What are the labels? Oh, so the labels on the bottom here, sorry, each one of these things, yeah, those are really small. It's super clear on my laptop here, John. So the buckets along the bottom here are all of the branches. So there's the third party only from visited, first party isolation, so going from left to right. That's all those different protection levels. The two on the very far right, the WTF ones. So the last one there is tracking protection, and the second to last is control. The y-axis here is just the average problems reported per user. So the values here for control group was about 0.24. So 0.24 problems per user were encountered in this branch. The dots here are the recorded value, and then the bars around it are the margin of error. So that's how, there's a lot of these graphs in here. So a lot of them follow this pattern where along the x-axis here is just one of the branches in the study, and along the y-axis is the quantitative value. So in this case, in the control group, the recorded value is 0.24, and for tracking protection, it was like 0.23 or something lower, right? Still within the margin of error of each other, so not statistically significant, but still, an interesting finding. So to understand why, every time there's a WTF moment, this is where I loved adding the comment box, because now I can go look in that specific branch in the control group and say, well, okay, well, what are the control users experiencing on the web if we don't do anything, right? If we just ask them, how broken is the web in general? We haven't touched it, right? What's broken? And so all of these comments kept coming up from people's problems in the control group. It was not responsive, it's slow, slower, slowly, slow, long wait, not always responding, slow, laggy, slow, doesn't load fast. And the last one that really killed it for me was something on this page is slowing down the loading speeds significantly. So if you run with any kind of ad block or tracking protection, you probably noticed when you installed it that the web got a lot faster. And this is a big reason because trackers slow down the web. So the finding that we got to say here was tracking protection, actually opposite of where we were concerned that people would experience a bunch of breakage and they would be upset at Firefox, it actually seems to fix websites by removing the trackers that break them, right? So that was a cool finding. So the next claim, do broken websites make users leave Firefox? We didn't actually have the ability, once people leave Firefox, we can't measure them anymore, surprise, surprise. But what we could do is by proxy sort of measure how many people were leaving this study based on which branch they were in. So our assumption here is that people who are disabling the study are doing it because the web is very broken for them and they're like, I need out of this study, right? So are the broken websites making users leave the study? So here we got to sort of do a pivot table, which I did not know how to do before this and still don't, but hey, look, fancy numbers in a chart. So what we really did was to kind of break down the different kinds of breakage. So whether, in this case, it was different websites that were broken along different protections. So in this really fancy chart, the top columns there are different websites like facebook.com, mail.google.com, mail.yahoo.com, all that kind of stuff. And then the left rows are the branches of protection. So don't worry about the individual numbers because really there's just a couple of outliers here that I've pulled to the top of this slide. That's resist fingerprinting seems to cause Facebook a lot of problems, right? And first-party isolation seems to cause YouTube a lot of problems. So yeah. Not those ones. This particular slide deck is online. Those are actually part of our internal telemetry dashboard. So the first time I gave this talk was at a couple of very small Mozilla meetups and then at the Mozilla All Hands, and now it's sort of like uncorked and just talk about it all the time. So you can't actually reach those, but I can show you my laptop after. The other thing we did looking at websites is we wanted to see what percentage of users left this study after they reported breakage on certain popular websites. So are there some websites that once you break them, they're done. I can't have this, you can't be breaking my YouTube, right? So the top site ended up being our own Mozilla support site, which was interesting. I guess people want help and you break the way they get help. They are really, really angry about that. So then there was also a lot of Google sites on here, not just popularity-wise, but on an overall basis. And then email kept popping up here too. So people, if you broke their email site, I gotta have my email, right? Live and die by email, don't break email sites. And then some of the longer tail sites that showed up was developer sites. So a lot of developers, we have a large cohort of developers that use Firefox. So we started seeing Atlassian and GitHub. Man, don't break those sites for developers, right? And then also maybe porn sites because Xvideo starts to show up, so people want their porn. So breaking workflow sites, the new claim was not just breaking websites makes people, leave Firefox or disable privacy protections. Now we can say something a little smarter, which is don't break people's workflow sites. So their search sites, their accounts, email, support, development, the things that people need to be productive, don't break those websites. Other websites, you can probably break them, right? So then beyond just websites themselves, now we want to know, is there certain kinds of breakages that make people stop using a certain protection? So by kinds of breakages, we mean the categories, so was it video, audio, images, layout, that kind of thing. So in this graph, we're just showing that this blue bar that is like the biggest thing on the bottom of all of these branches. So again, along the x-axis is the control group and then the first-party isolation, all the different experiments. The blue bar is the biggest one in all of them, and that's the other category. So my new claim is we're not good at predicting what's going to break when we do stuff, right? Like that's an unexpected finding. So we all thought we knew, oh yeah, well if you turn off Google Analytics, then this isn't going to work. And we don't know what the heck we're talking about when we said that. So other is sort of the big mysterious biggest bucket of breakage. However, when we look into some of the ones that were big in individual branches, so here again along the columns at the top is sort of the kind of breakage, so buttons or downloads or flash or font or images or layouts or logins, that kind of thing, payments. And then on the rows on the left-hand side here again is the different branch of the experiment that they were in. And the big ones here, first-party isolation causes a lot of login failures. And resist fingerprinting causes a lot of Flash problems. But Flash is going away anyway, so that's fine. And then we wanted to look at what % of users with certain kinds of breakages went on to disable the study. So now we're not looking at individual websites. We want to say, if you report, 94% of the users that reported screen breakage just disabled the study. So if you break their screen, in this case, the screen was usually the window size, because that's part of resist fingerprinting, is to lock your window size into a certain size. No, people do not like that, right? So they wanted to get out. So 84% of users reporting flash, 82% of users reporting login failures disabled the study, and then 64% of users reporting payment failures disabled the study. So those are big numbers, right? If you break logins and payments for people, they're going to leave, right? So there was a couple of caveats here, which was that screen and flash, which were our highest ones. They were only in resist fingerprinting, which ended up being high overall breakage. So we couldn't actually say a lot of smart things about whether or not it was the screen breakage that made them leave or the flash breakage that made them leave, or just resist fingerprinting in general is just bad, right? So we didn't have a lot of smart things to say about that. But we did notice that payment was an option that we provided for users in both the control and all of our third-party cookies branches. And since it was high across all of those, we can say, okay, payments, that's important, keep those working. And then login failures were also available for users to report in a lot of different branches. And again, across all of those branches, people disabled if we broke their logins. So now we get to say smarter things like that. So across all branches, breaking logins and payments makes users leave the study. So don't break people's email sites, don't break their developer sites, don't break logins on any site, don't break payments on any site, right? So just being able to say, a better level of detail of what's happening to users on the web when we turn these things on. So then finally, the last claim was, are there some existing preferences that could protect users without a lot of breakage? So this is back to the percent of users reporting even a single problem in our study. So again, along the left or along the bottom here, all of these different buckets are the different branches of the study. And the y-axis is the percent of users who reported at least one problem. So even in the control group, so the control group is our baseline. This is the one on the far right. So in this particular measurement, it ends up being what you'd expect. It's the lowest. But it's right at about 15.25, so 15.25% of users in the control group reported some kind of problem. Even on the far left of this graph, the very top one here is only 18.5%. So we're only talking about the difference between 14% of users seeing a problem and 18% of users seeing a problem. So that's not a big gap, right? So it's good news for us because it means that there may be a lot of opportunities, no matter what we do, that we can turn on even some aggressive protections, and not a lot of people are going to notice a lot more breakage than what they just perceive to be regular web breakage, right? But what we did find, numerically, is that 6 of our protections are actually within the margin of error of the control group. So that means 6 out of the 8 that we studied, potentially, maybe we can turn them on and no particular user is going to notice any more breakage than they would on a control version of the web. So that's a pretty cool finding. Another way to slice this was that average problems reported per user, like I said. So this is the one where we took all of the number of problems reported and divided it by the total number of users in that branch. And this is the one where tracking protection came out to be lower than the control group. But even across all of the other protections, 4 of our protections were within the margin of error of the control group along this particular measurement of the data. So these are just a few different ways of measuring the data, right? And they're just invented out of my head. There was no textbook on how to do this. So it's just things that I thought made sense. And then this is the percent of users who disabled the study. So again, along the x-axis, all of the different branches, and along the y-axis is the percent of users who disabled the study. The lowest reported one was around 5%, and even the highest was only 8.5%. So again, it's not like 90% of users in first-party isolation were disabling. It was only 8 to 9% of users that had to disable first-party isolation, right? So that ended up being like one of our most aggressive sort of protections that we could do, and even then, it's under 10%. Now, if you're talking about the entire Firefox user base, that's millions of people, and you don't want to give millions of people a really bad day. But, you know, it's nice to have at least our heads around the general scale of what we're dealing with rather than just a giant list of bugs in Bugzilla, because who wants that? So we had these 3 different dimensions, and I wanted to kind of invent an easier number to make it more obvious which ones, like how you could equate all of these things to each other on a single metric. So I invented this number called the composite breakage score that I ran past our web compatibility team, and they said I wasn't crazy, so I decided it is, you know, software for the ages. But it's essentially percent of users who report breakage times the average breakage reported by each user times the percent of users who disable the protection, right? So just multiplying all 3 of these numbers and then scoring them inside of each branch. So this is where the differences become a little more obvious. This is just easier for us to say, okay, overall breakage, not, you know, let's just boil it down to one number and compare these things against each other. And here we get sort of now what we expect, which is in the control group, it is the lowest observed group, right? So this is kind of what we expect in the control group. All other things, you know, maybe along certain dimensions, control group or protections are different from each other, but basically control is the lowest, so that's our baseline at around 12.08. Then the next one up was this origin only refer to third parties at 12.25, session only third party cookies at 12.44, tracking protection at 12.7, and those are the sort of 4 smallest bars here, and then they start to go up from there. But this is just an easier way for me to take all of the numbers and the data, boil it down to one number, one graph that shows you relative to each other, how do these things stack up and compare, right? This is just an easier way to sort of convey this to someone in a single image. We did have another WTF moment in this one where we have these 2 branches that are being pointed at. The first one is disabling all third-party cookies, and the other one is third-party cookies only from the sites that you visit. So the third-party cookies only from sites that you visit is supposed to cause less breakage, because if you go to Facebook and then later try to log in with Facebook, the third-party cookie will be allowed, so because you've already been there, and so that the whole reason that this from visited concept exists is to reduce breakage, to minimize breakage. But in our tests or in our data, again, we're looking at it, and it comes out that more people in that particular from visited branch were saying that we're reporting problems than just disabling third-party cookies completely. So what's going on there? So again, and this is another of those numbers, this was the average problems per user. The third-party cookies only from visited was the highest one, while third-party cookies was way over here, pretty low, and within the margin of error control. So again, what is going on here? Well, we go back to our comments that are in there, and I noticed a few of these. Someone said they got this message that the cookies are blocked. You need to change your browser settings. I can't access online bill pay because it thinks the cookies are blocked. I checked my options to say to allow cookies, what's going on? And then this one was, the message tells me my cookies are blocked even though my settings are to accept cookies. So what this looks like in, I think I can just pull it up. It's this one right here is what they're talking about. So they were coming over here and they had used custom settings and they looked at this, accept third-party cookies and site data. There's always from visited or never. So what we did in one branch was never, and what we did in another one was from visited. That's the only thing they would have seen if they came in and looked at this. So the conclusion that I came to was basically users don't understand what that from visited thing means. Like, it makes sense to us because we're browser vendors and maybe the most savvy of web users will understand this, but users were seeing, like, sites have adapted to cookies being blocked. And so when they detect that cookies are blocked, they tell the user, your cookies are blocked. And the user goes and looks at their browser settings and says, no, they're not. It says it's from visited. Like, that means they're not blocked, right? Well, we don't do a good job of explaining that. So basically, it tells us this from visited concept is probably a power user thing, and maybe there's a UI change. Like, maybe we don't put that in front of users. It's just confusing them, right? So that's another thing that we get to learn from this. Sort of those things we weren't trying to learn, but maybe we ended up learning. So based on all of this, the most promising preferences that we came up with was this concept of trimming the referrer down to just the website when it's sent to third parties, letting people enable tracking protection, and then enforcing session-only third-party cookies. But we have to, because we're Mozilla, we have to think about, number one, we have to think about what are the user values of these things that we can do. So what is the value to the user when we do these things? So the origin only refer to third parties, like I said, it reduces the detail that's sent to trackers. So a tracker may know that you went to webmd.com, but they don't know what particular communicable diseases you were looking up on webmd.com, right? Like that'd be nice if they didn't know that. So yes, okay, this user goes to WebMD, they're a healthcare person, but let's not exactly pry into all of the articles that they were looking at, right? So that's cool. It had very few login failures across the board, which people don't like login failures, and had very few email failures, or email breakage. So this is a really promising pref. Another nice thing, so the next thing we always have to think about is not just what is the value to the user, but what does this do to the web ecosystem at large? Because if you do something on the scale of Firefox, it affects the entire web ecosystem. So how does this actually affect the web ecosystem? Well, the nice thing that the ecosystem, like this, does not block ads. This is not an ad blocker, right? This is a tracking minimizer. This is you don't get to track me as detailed as you used to, but I can still see ads, but maybe the ads are just, they think that I am into my own personal health, like I'm into my personal health, but they don't exactly know what diseases I have, right? So the ad can still get through, it's just not quite as invasive. So the ecosystem likes this because it's not an ad blocker, right? It shows ads. A downside here for the ecosystem is that they use referrer data to guarantee ad policies. So if you put up ads for your brand on like Google AdWords, AdSense, a brand can say, do not show my ads next to content that is, extremism or violence or whatever. And in order to actually be able to audit that, they need some way of knowing exactly which web pages it was shown on. Now, for the larger content sites like Wired.com, it's not there. But for user-generated sites like Reddit, impossible to know unless you actually dig down into the actual Reddit article that the ad was shown on, right? So for tracking protection, the value to the users is that it blocks all the known known trackers completely. It gives you a big speed boost, and there's very little email breakage in our studies. But users will start to see ad blocker walls or paywalls, right? So you go to a site and it says, hey, we noticed you're running an ad blocker. Please disable it on this site, or subscribe, or something like that. I haven't done the numbers, but I'm pretty sure everybody just clicks back when they hit that. That would be interesting to know. So the ecosystem doesn't like this clearly because they put up these ad blocker walls because this blocks ads. Session-only third-party cookies, so this limits the duration of how long you're going to be tracked. So you won't necessarily be tracked from the time that you start researching your travel holiday all the way to the time that you get back and want to buy the picture book from Disney World or whatever. This is just like session by session. They can see what you did in a certain session, and that's it, right? Very little email breakage here. There was some login and some unexpected sign-out failures, mostly because every time you quit Firefox, you're probably going to get signed out in a lot of these cases, especially if you're using like a third-party identity provider. So again, the ecosystem likes this one because it doesn't necessarily block the ads. It just limits the duration that ads can track you. So the key takeaways that we had, tracking protection doesn't seem to break websites as much as we maybe feared. Breaking the workflow sites is what makes users sort of disable privacy or security protections. And yes, there's definitely some things that we could do to protect users with minimal breakage. We had some post-study user surveys, but I can get into that if somebody asks a question at the end. So this presentation I gave was at the end of Q3. So in Q3, Q4, based on this study, we actually added the option to turn tracking protection on all the time in the Firefox Quantum launch. So this is something that a lot of people have been very concerned about doing, just because of the ecosystem effect that it would have. But based on this sort of study unblocking, like, hey, it's not as scary as we thought, let's go ahead and do it, then all the product deciders at Mozilla can say, yes, we're going to do this. We're going to let people turn it on all the time. So that was a pretty cool outcome. And then this is something that I got to work on that just launched. I think it's now in beta channel, so it'll be in a Firefox coming to you soon. But basically, in private browsing mode, we're trimming referrers to origins. Just if you're in private browsing, you don't want trackers that might be off the block list or might be skirting the block list or just accidentally getting leaked because they're not technically a tracker. We just don't want to send that full path information. So that is coming. IP address study may be coming. And then that's pretty much it for this part. Yeah, that's it. So I can take questions. I was going to pull up this other survey stuff just in case people wanted to see it. But yeah, questions? Yeah.
So when the user opted out, they opted out of the entire study or just for that particular website?
Yeah, so the question was, when people opted out, do they opt out of the entire study or the particular website? So the disabled privacy study disabled the entire study. So across all websites, they just needed to get out. The tracking protection branch, the way that tracking protection works is it actually onboards users when it's enabled and tells them you can disable this on a site-by-site basis, which is probably a big contributor to why people didn't feel the need to disable and people were reporting fewer problems because they get out of it. That actually told us that what if we could do some of our cookie controls or referrer controls or fingerprinting or whatever on a site-by-site basis. So maybe that's the key. That's like, there's a lot of per site cookie settings work going on right now too. So that's a really good question. Any other questions? Yeah.
So in your methodology, was there any kind of adjustments for, like, I just know that I'm one of these users, like people that just flat out didn't use the button?
Yeah, so we had, there was a good, I want to say, challenge or note about the methodology that we didn't have a positive control group. So our control group was a negative control group, basically saying we don't do anything. The positive control group turns out to be hard to do in situations when you're doing research that has not really been done before, which I couldn't find any other research that was like this. So usually the way a positive control group is, you treat previous research's like most significant finding as a positive control group to your own, and you compare against that one, right? We didn't have that, so if I were to do it again, maybe I would either treat one of these findings as our positive control group, like resist fingerprinting or first-party isolation, or what I would do is literally have a branch that every 5th page load, I would just put a big fat thing on your screen that says, your privacy settings broke this page. And if nobody's clicking the button then, like, wow, okay, got a problem.
The page that had the most people who disabled the study was Firefox's own help page. What was breaking on Firefox's help page?
So it wasn't Firefox's help page necessarily that had the most amount of breakage. It was that when that site was broken, that's when that had the most number of people leaving the study, right? So I actually didn't dig into which particular protection it was in that case. So I think on one of our pivot tables, look, let's go check it out. Back up we go. So click on this link here. Hopefully my queries are still working. This runs on a really big cluster, so sometimes the queries take a long time. Support, oh, that's category, not site. Yeah, so we did it, yeah. So this one is by site, but not type, and this one is by type and not site. So we would have to do another sort of cross-join on it to have the top would be the type of breakage, and then the left side would be the site. And we would look for where sumo and sort of which types of breakage people were seeing on it. So I didn't do that particular analysis, but.
Did you say you have any follow-up studies?
We have currently, I'm doing a IP address trackability study that is essentially measuring to see how unique and how stable people's IP addresses are, to see if an IP address by itself is enough to track you. So leave alone fingerprints, cookies, all this other stuff. If someone has your IP address and maybe a user agent string, is that enough? So we're still doing the queries on that. Preliminary findings, well, really the queries that I've done right now aren't, not even worth saying what they are because it's just so full of asterisks on top of all of the claims that I might make that it's not even a real study yet. But it's, I think we should be done with it by the end of March. So, the other things, there's a study going on right now that I think is really cool. It's being built. I don't know if it's been deployed yet, where in addition to, we'll turn on tracking protection, and then what we'll do is inside of this Firefox new tab, every time you open a new tab, we have some different way, like I've customized mine to take all of the distractions away, but the default new tab experience has some UI elements on it. And so one of them is sort of this Firefox thing up here. We have a study going where in this area, we will display the amount of time that we've saved you by blocking trackers. So just the time you spend sitting at a web page waiting for it to load because of trackers, which over months ends up being hours of your life just wasted waiting to be tracked. And then also what was it? There was time and there was another metric, bandwidth. And we could potentially, we'd have to fuzz numbers. We could potentially do battery. So on mobile, like how much of your battery is just being burned up by trackers, right? Like, hey, tracking, it's the new crypto jacking. But it's, all these kind of trackers that get loaded do things and they're invisible. So this study is, if we make this visible, do people opt into more tracking protection and stuff like that? So.
That was my other question too, is some people, I think of the older generation or just some people are sort of, they don't take the time to explore that, but I think it was right now.
Yeah. We've done, there is one of my colleagues, Francis Jabra, is our user researcher in privacy and security. And he has done a lot of really, really good secondary research where he's gone and looked at like what DuckDuckGo and a couple other people are doing in their own user research and sort of applying that to us at Firefox and then doing our own research. We actually did a couple of user research workshops in Tulsa. So he came out to Tulsa and sat down with a bunch of people and asked them about advertising and stuff like this. So yeah, he's done a lot of really good research, and one of the things that he's said to us that maybe I just like it, so I latch onto it because it fits me, is people want a single button. They want the privacy or security switch, and I flip it and I'm done. Like people don't want the, oh, well, if you do this, that protects this, you do this, which is super annoying because all the security people, that's all they give you is a whole bunch of trade-offs, like a laundry list of trade-offs, like, oh, well, yeah, if you care about the FBI, do this. If you don't, do this. If you care about trackers, do this. It's so super annoying to talk to security people because people just want like one switch. Like, no, look, and like our goal is to make that one switch like Firefox. So use Firefox, we will take care of it. We will figure out how the web breaks, we will figure out what the worst adversaries are, the worst things that can happen, use Firefox, and we will do the hard parts so you don't have to do the hard parts. So that's the goal, and that's what I keep trying to, based on his research of people wanting the single switch. I'm like, that single switch should be Firefox.
What about competitive browsers and because they don't?
Yeah, so the question was, what about competitive browsers? I am being streamed right now. So I will say every browser maker that I've had an opportunity to talk to, all of their engineers are well-intentioned in the right place. So that's Chrome, Safari, Edge, Firefox, Brave, all this, any independent browser, like they all get it, right? They're not always in a business position where they can do as much as they want or would like, or sometimes they really have legitimate business reasons, not just business reasons of their business, but like web ecosystem scale type concerns about doing certain things, right? Which are totally legitimate and why we try to think about those things too. But to kind of, I know that was a very diplomatic answer, and I'm trying to fish in my head for the clear answer that I can give that is still diplomatic. I'm really impressed with what Apple and Safari are doing with intelligent tracking protection and their new storage access API to help mitigate for web developers like us that depend on some of that stuff, and basically say, like, you can do it, you can ask for, you can get the ability to do sort of cross-site storage if you need to for the reasons the user is informed, and it doesn't expose them too much. So they're doing really cool stuff. I also like what the browser Brave is doing. They're really, really audacious, really ambitious. I think they're diving into the sort of messiest part of this whole thing, which is you have to fix the business model of the web. Like, you cannot just do this on just the technical merits or just the technical basis alone. Like, it goes part and parcel with how people get online. So they're actually tackling that head on. They've got a whole browser attention token or Brave attention token blockchain something also, and I couldn't even figure out how to get a bat. And I was like, okay, never mind, I don't know how to do this. So, but I like their browser, I like their approach, I like their stuff. I do like a lot of, especially on the security side of what Chrome is doing. So Chrome is really pushing aggressively for HTTPS adoption, sort of across the board, and starting to not mark sites with just, well, let's see. So if I go to our conference website up here, let's see, how do I do this? Is that working? Whoa, it's working. So here in a browser bar where there's no HTTPS, right now it just has, information, and you have to jump down here and it says connection is not secure. Chrome and now Firefox, based on us basically hearing about it in the sort of web platform channels and discussion lists, we're just going to start to put the words not secure next to these sites if you do not have HTTPS, right? And the ultimate goal is deprecate HTTP, like it needs to be gone. Because all of the things that a tracker can do to you, if it's over HTTP, anyone on the Wi-Fi network could do the same things to you. So they could see exactly what pages you're visiting on WebMD. They could watch you browse, time after time after time. They could build up a profile about you, like all of that stuff. And that's not just, the classic, I don't have my hoodie on, but the classic, hoodie ninja hacker in a dark room somewhere doing that. That's like your internet service provider or the NSA if you're concerned about the NSA, right? Or foreign entities, like all that can happen over HTTP. So they're really pushing for HTTPS adoption, and so I really like that and can get behind that. So yeah, as far as browser vendor goes, like they all kind of have the sort of motivations that you would expect from each of them. I mean, Mozilla, we're a nonprofit, and Apple is basically like they kind of don't care if they break the web ecosystem because they don't make their money there. They make their money on devices and gadgets, so they're like, we'll just do this thing that differentiates us from Google so we can sell more phones, and they're fine with that. And they don't have a concern for the larger web ecosystem. They're like, whatever, just use the App Store, right? They've got an answer for that. So that's kind of their play. Google and Mozilla very much care about the health of the web at large. Yep.
Is there any chance of getting a Indian Mozilla developer article for web developers that want to comply with some of these settings without breaking the website?
Yeah, so there's some on developer. There's a good place to start is just web security. So there is a web security section, and then I think there's even guides for privacy in here, maybe. So the first answer is there's a web security section on MDN that's really good. The other one is if you go to privacy, I'll put an asterisk at the end of this particular suggestion. But there's a site called privacytools.io with a section about privacy related about config tweaks. So this has a lot of the settings that we studied are actually in here. And I know that because I sent a pull request and put them in here. So you can look through this list and kind of say, okay, you know, if the session if the cookies expire at the end of every session, let's make sure our login experience is super fast, because people might get logged in may have to log in a lot, right? So don't ignore your login page if you think people are going to be disabling their cookies, right? That's kind of an easy a guideline for that one. I will put a big asterisk. If you go to this privacytools.io site and you do the privacy-related tweaks, ignore the ones that they talk about safe browsing. So keep safe browsing enabled. I guess I can leave it at that. There's a GitHub issue and pull request with a lot of trolling, mostly of me, on these two particular settings. But I'll just leave it at that. So if you do go to this site and look at their things, keep safe browsing enabled. Like it's called safe browsing for a reason. So keep it.